This lesson is all about one word, iteration. Um, we have to first of all understand what iteration is, what the process means, and we're going to learn how to use a calculator confidently to perform iteration. Now, you need to have a good scientific calculator in order to do this. And then you're going to derive the iterative formula from the original equation, which is actually the harder part of it. It doesn't come up often, the last part, but when it comes up, usually it does trick up a lot of students. Right, anyway, so what is iteration? Well, iteration is a mathematical method to approximate the solutions of an equation. This formula can be repeatedly used to find the next term. Now, not all the equations could be solved easily. Now, quadratic, we have the quadratic formula, but what about cubic then? We don't have a formula for cubic. So let's say if I asked you to solve x cubed plus 4x cubed plus 10x cubed, 10x squared, nope, 10x squared plus 10x plus 6, let's say plus 6 equals 0. How do you solve it? You can't solve it really. Well, you can try to put in the Google it and try to find a cubic calculator. It will solve it for you. Or, now that's called cubic equation. If we go a bit further up, that's called quartic. Let's say 4x to the power 4, quartic plus 5x squared plus 3 equals 0. There's no way you'll be able to solve it. Now, one way to estimate the solution, or we call the root, is what we call by iteration. Iteration helps you to approximate, just to guess the location, just to guess the location a bit more accurate, like a GPS. Okay, where the location of the root is. Anyway, the iterative formula usually looks like this. Now you have a xn plus 1, which is the next term, and then you have a formula, and then with an xn. Xn means the previous term. So it helps you to work out using the previous term to work out next term, and then using the new next term to work out the following next term. X0 is called initial value. Now this is also sometimes, sometimes x1. Now some question like to use x1 as a first value as well, which is equally fine. They will tell you the word initial value, so you know if x0 is the initial value, then x1 is the first term or next term. If x1 is initial value, the next term will be x2. You can use x2 to find x3, x3 to find x4, etc. Now this is the key part. Okay, you might want to highlight it, whatever way you want to remember it, or you remember it. As you do more, you'll probably get used to it a bit more. To use the formula on the calculator, follow the steps below. First of all, we're going to type the initial value, and then we'll press equal sign. And then we're going to type the iterative formula, but replace the xn with the answer button. Now, if I use this formula as an example, in a calculator, what you'll be typing in is square root 4 plus answer. So you replace xn with the answer. I will show you and demonstrate how to do that in example later. And once we've done that, we just press equal and equal again to find the second and again to find the third term, etc. Okay. Now to derive the formula from the original equation, you want to work backwards from the formula. Now I'll show you again. I'll show you. It doesn't often come up, but if it comes up, you have to be smart and try to remember how to do this. Okay. The first example here, using xn plus 1 equal 4xn minus 2 with x0 equals 1. Now remember, x0 equals 1 means initial value. That's the initial value. Okay. Find the value of x1, x2, x3, and x4. In other words, they want you to perform iteration 4 times, because first time to find x1, second time, third time, and fourth time. Now I'm going to show you without a calculator how this iteration process work. So without a calculator, now so we know x0 is 1. That means if I want to find x1, I can use the formula for over. If x1 is the next term, then the previous term will be x0 minus 2. So we know x0 is 1. So I can rewrite the equation as 4 over 1 minus 2, which is 4 over minus 1, which is negative 4. For x2, that will become 4 over the previous term. If the next term is x2, then the previous term will be x1 minus 2, which equals to 4 over, now x1 now becomes minus 4, so minus 4 minus 2, which is 4 over negative 6, which is negative 2/3. So this is how we use the iteration. That's what the calculator does. Now you have to know this because sometimes when they give you a problem solving question, in rare cases, you won't have a calculator do it. You need to show some working out, and that's what you need to do. That's what iteration means. You have to reuse the previous term. You have to use the previous term to find next term. Okay. So right. Anyway, so let's use a calculator to see how it works. Okay. In a calculator, first of all, if you follow the steps, first of all, the steps tells me to put initial value, then press equal. So the initial value is 1. So 1 and then equal. After that, the next step is to put in the formula. So the formula is 4 over xn. Now you have to replace xn with the answer button. So it'll be answer minus 2. So and then you press equal. So you get your x1, which is minus 4. And then you press equal again. That's your x2. Guess what? If you find an x3, I guess Dora would know.
Do you see Swiper the fox? Where? Right behind us?
Minus 3 over 2. So press equal again. You find x3 equals minus 3 over 2. So I can write here x3 equal negative 3 over 2. And then I'm going to press equal again. Negative 8 over 7. And that's the answer. All the 4 answers. So x1, x2, x3, and x4.
That was easy.
One more example. An approximate solution for the equation, so there's a cubic equation, can be found using the iterative formula. So this is the formula. Okay, don't get mistaken. You're not using this one, you're using this one. Okay, so the one with the n plus 1 in the end. With an initial value of x1 equals 2.5. As I've told you, some question like to use initial value using x1 rather than x0. So just be mindful of that. It doesn't really matter. Find the first 5 iterations correct to 4 decimal places. Okay, so you can round it to 4 decimal places. Well, how do we do it? Well, calculator. Okay, so first of all, press AC. Now, some people do not know the difference between AC and on button. Both clear off the page. But if you press the on button, now take note of the arrow sign in here. When you press the on button, I press AC and on. When you press the on button, sorry, this is the emulator. It doesn't quite work in my way. If you press it on, it will refresh the page, but the previous working out will be gone. However, the answer button will still work. For example, press answer, it will still work. However, you cannot trace anything before the last line. So as a rule of thumb, if you need to use anything in the previous steps, press AC. But if you do want to clear off the page and clear off any history, press the on button. Okay. Anyway, so we start off with x1 is equal to 2.5. So as I said, first step, put the initial value and then press equal sign. Okay, so we are storing this value in the calculator previous step. Next, we're going to type in the formula, but replace xn with the answer button. So cube root to begin with. So cube root, so shift square root button on my calculator. If you've got different model, just be, then do your cube root. 15 xn. Now you can do 15 answer, but personally, I would do 15 times answer. It doesn't make a difference in the calculator. Calculator is just too smart for us. And then plus 3. Right? And then equal. So that's my x2. Now I need to round to 4 decimal places. So 4, 3, 4, 1. So x part A, x2 equal 3.4341. Next, press the equal again. 791. If you round it, 7917. So x3 equals 3.7917. Press equal again. 3.9121. Some of you might be thinking, if I mess up, what should I do? Start all over again. Okay, because if you mess this one up or mess the previous one up, it will have a knock-on effect on the rest of the answers. So if you mess up at any stage, or if you're unsure if you click the right button, do it again. Now for iteration, I do suggest students to do the whole thing twice. So finish it once and do it again, because sometimes you got like me, I got a fat finger. Then you know sometimes you might click a wrong button, or or you copy the wrong thing. So just do it twice and double check your answer. All right, we're human. We are bound to make a mistake. So x1, x2, so 2, 3, 4. I need 5 iterations. 1, 2, 3. I need 2 more. 9, 5, 1, 1. And then press again. 9, 6, 3, 6. Okay, so that's the 5 iterations. Okay, part B. Verify that 3.97 is a solution of the equation correct to 2 decimal places. Now these numbers, if you look at these are solutions, but these are approximate solutions. Now you can see the increments going up is getting smaller and smaller. Now, what do I mean by that? Well, if you have a look in here, 3.43 going 3.979, that's a 0.36 difference. In here, that's around 0. Quick maths, 1.2 difference. That's a 0.04 difference, and that's a 0.01 difference. You can see the increments going less and less. That means we're getting closer and closer to the answer. Think of it like a moth. I'm not sure if you see a moth glowing into some light sources. So here's a light bulb. Ding, 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 ding. And then there's a moth, black. Okay, moth, then I draw moth. So when a moth goes to light source, it doesn't go there directly, right? It doesn't go there and burn itself. What it does is it goes round and round and round and round coming in. Now, how do we apply this sort of scenario into iteration? Well, think of it as the initial solution. It's quite far away, but then we're getting closer and closer and closer to the actual answer. All right. So, what's next then? Next, part B. So what we're trying to do here, to verify 3.97, we want to try to find 2 solutions that could round 2 iteration approximate solutions that round to 3.97. Now these one round to 3.96, so we can't verify 3.96 is a solution. We need 2 of them. So let's keep going. Okay, let's keep going. So find the next one. Oh, 3.967. So that's 3.97. So we're going to write all of them. So 3.9675. So x part B, I got x7 equals 3.9675. Right. This round to 3.97, so I can approximate to 3.97. Curly equal means approximately equal. So this means approximate it to. Next one, press equal again, 3.9687. Oh, so that round to 3.97 as well. So 2 solutions round to 3.97. Therefore, 3.97 is a solution. So part C, show that the equation x cubed minus 15x minus 3 can be rearranged to this equation, x equals cube root 15x plus 3, and explain the relationship between the values that we found, x to the x6, and the equation x cubed minus 15x minus 3. So, if you remember what I said in the beginning, to derive the formula from the original equation, work backwards from the formula. Right, so this is what we're going to do. Part C. Now, first of all, we're going to make a draft. Now, I'm going to use orange color for the draft. You can show this in exam, but you will have to write the proper answer as well. So that's the draft. Now, you'll need the draft to help you to structure the formal answer. So the formula was x equals cube root 15x plus 3. So what we can do here is, we know the original equation has one side equals 0. So we're trying to make everything to one side. So first of all, to get rid of cube root, we cubed on the other side. So x cubed equal 15x plus 3. And then to make everything equal 0, I can bring the 15x and 3 to left-hand side. So x cubed minus 15x minus 3 equals 0. And that's So that's how we got to the equation. Now the question wants us to start from the equation to work backwards. So this is the proper answer. So that's the answer. Okay, so that's what you show in exam. You start from x cubed minus 15x minus 3 equals 0. So start from here. Next step is to bring the 15x plus 3 to the other side. So x cubed equals 15x plus 3. And last step, we cube root it. So x equals cube root 15x plus 3. In a nutshell, what it means is you just sort of undo the steps. Do the steps, but in reverse order. Okay, right, so that's how we could rearrange it. Next step, next thing, we're going to explain the relationship. So to explain a relationship, we'll have to say because x equal cube root of 15x plus 3. Oops, wrong. Let's try again. Because x cubed minus 15x minus 3 equals 0 can be rearranged to x equals cube root of 15x plus 3, and therefore the values of x2, x3, x4, x5, and x6 are the approximate solutions to x cubed minus 15x plus 3. Okay, so that's what you have to write, explain the relationship. Well, why, you'll be thinking. The reason being is x equals this one is actually the iterative formula. So what you mean is these x2, x2, x6 are helping you to work out the solution to this equation. But this equation is actually, this formula is actually linked to the original equation. So whatever you found in here is actually directed to the equation. All right? Here comes 2 practice questions. Pause the video, have a go at the question. When you're ready for the answer, you can press play. Here are the solutions. If you got it right, then well done. You can skip to the next part. But if you got it wrong, then I'll go for it with you. So first of all, question 1, starting from x0 equals 3. So let's do it. X equals 0, 3 means 3 equal. Next, I'm going to type in the formula. So start from a fraction, 9 on the top, denominator. There's a bracket, so we follow it. A bracket, answer, close bracket, squared. And then minus 4. So press equal once. S and D means change your decimal, 1.8. Equal again. Negative 11.84211. Press equal again. 0.06606. Press equal again. Negative 2.2546. Yep. Okay. Right. Question 2. Show that the equation could be rearranged to give this one. So what we can do first of all is we can work backwards. So draft. So let's do draft again. So draft. So we start from the formula. So x equals square root of 7 over 3x plus 1. Get a square root means square on the other side. So x squared equals 7 over 3x plus 1. We multiply, when you make one side equal 0 and they have no fraction, so we're going to multiply denominator to left hand side. So x squared bracket 3x plus 1 equals 7. Expand the bracket. So 3x cubed plus x squared equals 7. Bring a 7 left hand side. 3x cubed plus x squared minus 7 equals 0. So we've got to the equation. Now next step, we have to work backwards to find to do the answer. So that's the answer. Okay. So start backwards, start from here. 3x cubed plus x squared minus 7 equals 0. And the next step, we'll bring a 7, just copy it basically. The next step, factorize it. Divide it. And then square root it. Right? If you have a question, why do you have to do all the fuss? Why can't we just start from the bottom, from the very beginning? Well, one, It's quite hard to actually do it without working backwards to see the steps in between. And the other question is, why can't we just start from the formula? Well, the answer to this question is because the question wants to show from the equation to the formula. It doesn't mean backwards. Okay, so for example, can you show me the journey, let's say from your home to the school? Can you show me the route that from home to school? But it doesn't mean when you show me the route from school back to home, it's different. It might be different. It might be a different route coming back home from school. From home to school, it's a different route to school to home for some people. Same in here. They want you to show me the equation from here to here to the formula, so you can't do it backwards. Okay, right, part B. X1 equals 1, so let's start again. So x0 equals 1, initial value 1 equal, and then put in the formula, so square root, fraction 7 over 3xn. So 3 times answer plus 1. So that's 1.32287, or 8 rather, but it doesn't matter, it's 2 decimal places. Next one, press equal again, 1.19. But I want to do 3 times. Sorry, I forgot 3 times. And last one, 1.24. So 1.24. So x3 equals 1.24. And that'll be the final answer.